All right, take it off, Alejandro.
Okay. So can you guys see my screen?
Yeah.
Okay, great. So I'll go ahead and get started then. So yeah, so this is the FaceID kind of login page. So I'm just going to go ahead and just create a new user. There shouldn't be any users at the moment. So yep, no users. So I'm going to go ahead and create my user. So you take a picture pretty much, you put your email address. In a normal application, you probably have a password, even though that you're going to authenticate with the webcam, but just left it simple for now. So we'll go ahead and create that user. And so, okay, I'm signed in. So I'm going to sign out, make sure that my user is there. And yep. So, okay, so then I'm going to log in now. And it kind of logged me in. So yeah, so pretty much what happened here is just that it took a picture without there being like some sort of video component there. So it's able just to take a screenshot without in the background essentially, and it detects my face, and then it does a comparison to all the users that exist in the system. And it essentially allows me to log in. So if I go and like, cover my webcam, it won't work because it won't detect a face pretty much. And in order for this to be a little bit more exciting, there would need to be more people here so that, different people can log into different accounts and stuff. But, with COVID, obviously I can't have anybody helping out in the demo, especially without masks. So yeah, so that's pretty much it. It's a pretty simple one, but hopefully it logs me in again. There we go. Nice. So yeah, so that's pretty much it. It's yeah. If you guys have any questions, yeah, let me know.
Nice. Does it work with a mask?
Actually, I was trying, and somewhat, yeah. It seems it's able to encode the eyes well, but yeah, I could try it though. So I'll just cover. Okay, no, I didn't find it with covering the face.
How about with a picture of you?
Pardon?
How about with a picture of yourself?
Oh, a picture of myself. Yeah, no, exactly. So it's so this sort of login system wouldn't be the most secure, because you could print out a picture of somebody, which is what I tried to do today to demo other people's like login accounts. But essentially, in order to combat against that, I think the most secure way to do something like this for the web would be actually to take in a video. So you would probably just take a video of somebody for a few seconds, and then just see those small variations in kind of the facial and kind of moving around, and being able to use that as a complete way to log in, essentially, instead of just using a static picture. Because with static pictures, of course, they could be, they could just be fake. So yeah, but that's a good question. Yeah.
What sort of libraries or APIs did you use for this? And also, could you just like write down your password on a piece of paper and hold it up to the screen?
Oh, yeah, for sure. Well, you mean just not show a face, or?
Well, is it specifically geared toward faces?
Yeah, it's only faces. Yeah, so it's I don't think it even, if it doesn't detect a face, well, I'll just do half a face. Yeah, it needs to detect a full face to do the login.
You have to stare directly at the screen, or can you just do a little variation?
Actually, so yeah, that's another good question. Yeah, it has to be kind of, you have to be facing directly at the screen, because if you do like a little bit movement like that, since I only took one photo, it doesn't really know how to encode me in different directions. So for now, it has to be looking straight. But actually, like a really simple variation on this is just going to be allowing multiple photos. And so that would be kind of like the typical Face ID, kind of like you look up and then around. And then now all those pictures, it would know and associate with one user. So the next time you log in, you can log in at an angle if you want. So, but yeah, as for the libraries that I used, I didn't really want to focus too much on the actual cropping, like detecting the face and cropping it. So, so I used OpenCV for that. The rest I kind of tried to do from first principles without kind of looking around too much, and kind of after I implemented it, then I started to kind of look around to see what other people did. But my approach was then, once I had the picture of the face, I did kernel PCA on it. So it's kind of like PCA, but with essentially using kernels. So it's able to kind of find like a non-linear manifold essentially in a when it's plotting the points essentially. So it's a generalization of PCA, but then I found that kernel PCA didn't really work that well. It was too computationally expensive and it wasn't given that much benefits. So I just reduced it down to PCA. And PCA is just a way to reduce something that's really high dimensional into lower dimensional space. So it pretty much took the face, which is, you know, every pixel's one dimension essentially. And it was able to find, using a large data set of like 13,000 faces, it was able to find places where the pixel intensities vary the most and reduce that down to a lower, like 300 dimensional vector instead of like 20,000 pixels or something like that. So essentially PCA reduces the face down to 300 dimensions, or the picture of the face in 300 dimensions. And then once I did that, I can take a new photo and transform it into this lower dimensional space, which is what PCA does. And then essentially just do cosine similarity with all the pictures that exist in the database essentially. So it's just finding the angle between that really high dimensional those high dimensional vectors essentially. And I was able to determine that threshold by experimenting using a classifier. And by training a classifier on my face, I was able to determine a good threshold for the cosine similarity essentially.
And then after you looked into how other people had done it, did you see any places where you're like, oh, I really should have done it that way?
Yeah, totally. Yeah. So one thing for sure is that I knew from the start was that I think convolutional neural nets would have been definitely a better way to go approach this. But I don't have a ton of like kind of CNN experience. I've just worked with like just basic forward propagating neural nets. So so I didn't kind of approach it that way, but I did see that people online were, one guy that tried to implement Face ID, he used neural nets to kind of reduce, do dimensionality reduction. So essentially reduce it down to an embedding space, but using CNNs to kind of like a word to vec approach, if you guys have heard of that, where it trains it on, and it's kind of like a transfer learning problem where you train word vectors on a large data set, and then you can use those word vectors to transform your features so it could perform better. So that's kind of like essentially the approach that he did. He trained kind of these vectors on a large data set of faces, and then was able to transform his face into this space, which was a little bit better because I think the CNNs will be able to encode the face better, since they won't be as sensitive to changes in light and translational invariance, translational variance, I guess. So yeah, so that approach was definitely the best one that I saw. And he was able to get pretty good accuracy. And his model also did something really interesting where it actually tried to minimize the distance between the faces in the same class, but also maximize the distance between faces of other classes while he was training that model to put it to reduce the vectors into a lower dimensional embedding space. And he, yeah, so that was really good. And yeah, that was the best approach that I saw for sure.
Do you have a way to calculate your accuracy? Like say the percentage of accuracy of your approach, or you didn't?
Yeah, I do. Yeah, I was first playing around this in a notebook, a Google Colab notebook, and so it was like I was just playing around with different ways. But if I recall correctly, last time since I don't have like the biggest data set of my face, unfortunately, I only took like 13 photos, but I think the accuracy was like above 90%. But the thing is, I only took photos under a certain lighting condition, and I didn't try more lighting conditions, and I think that would have probably affected the accuracy, because this method is really sensitive to lighting conditions, because it turns it into grayscale first as well. So then if there's like a shade in your face, it's not gonna recognize it properly.
And then how are you running this thing? I noticed you're using Google Cloud. So, and you said you use OpenCV. So how did you integrate things? So how is this working behind the scenes?
Yeah, so right now this is all kind of running locally. I can kind of deploy it if I wanted to Google App Engine or something like that. So this is just like the Python code is actually just pretty small. It's actually like less than 200 lines of code. So this I could just deploy in Google App Engine or something. And the front end is built on React, and it could just be deployed into Firebase hosting as well. So I kind of just wanted to make use of one cloud provider, and just, so this is using Firebase auth as well. So Firebase auth and then Firebase storage for the images. So the images would actually go here, and yeah, so this is kind of an image for this particular user, which has this ID, and then this is kind of the user as well. So yeah, so this is just using mostly just Google, but it could be deployed as well.
Cool. And then why did you decide to do this project in particular? Did you want to like learn something, or did you have experience with that sort of stuff?
No, I think it's the reason I kind of chose it. I didn't have too much experience actually doing data science stuff, but I actually spent I think a little bit too much time in the theory aspect with like data science. Like I probably spent like I kind of went back and took a few university courses as well, some stats courses, to try to get a better fundamental understanding. But then I just never actually used libraries to put something together. So this was kind of one of my first projects, actually, just using scikit-learn and just building something. So yeah, so I think that's why I wanted to do, just use something with data science, but also not too complicated, but also something I could kind of improve over time. So yeah.
And if you had more time, what else would you do, or what would you change if you had more time?
Yeah, for sure. So yeah, I would definitely change this to a kind of transfer learning approach, or using, or even if it's definitely using convolutional neural nets, because the value of convolutional neural nets are exactly the fact that you don't have to translate or transform like a lot of images before you train your model. If it's good enough, it's going to pick up those like small features that you're not going to need to like shear like faces to like try to get the train a neural net to pick up those small features. So convolutional neural nets are good because they pick up kind of locally like they pick up kind of other kind of pixel intensities that might not be near where their assigned pixel intensity is. It's just really good for just picking up those features essentially without doing a lot of transformations. So yeah, I would do definitely a convolutional neural net approach, but I think I would need to learn a little bit more about how it can actually be used with as a dimensionality reduction method first, and then kind of go from there. But before that, I would even try just using more kernel PCA to try to see if I can get better accuracy using this method first as well.
It's interesting that you used a simpler method and you got what you wanted, which is for the purposes of this demo is working. So, and then you could make it more complicated later, but it's nice that you kind of did something simpler to start, which is pretty cool.
Yeah, yeah, for sure. Yeah, it definitely has some small limitations, like if like you're too tilted to the right or something, and maybe it won't recognize your face. But yeah, I think it's good for like an MVP. You just look at the camera and it logs in. So yeah.
I'm just curious, if you create a user with like a right tilting Alejandro, would it recognize like the right tilting Alejandro when you log in?
That's a good question.
Versus the center looking one?
Yeah, that's a good question. So I think so. I think it will. So I mean, I could test it. So I could go like, so I'm tilting to the left, and then I take a picture. So, okay. So then I'll create the user. There we go. And then sign out and then log in. Okay, so I'll try to tilt. Yeah, so yeah, I found that user. Yeah, so exactly. So essentially what would happen is if you did the same approach and then you just took it in different angles, and then you just bucketed those as the same user, it would kind of still work without doing the whole convolutional neural net thing. But it wouldn't be as nice because you're not, yeah, it's still really dependent on lighting conditions and things like that. So, but yeah. Yeah, it's a good question.
Did you hit any roadblocks while doing this, or like anything that was hard that you had to figure out?
Yeah, so well, actually, I've been working with Python doing like physics simulations for a while, but I never really wrote an API and like a kind of just like a good backend that I wrote from scratch. I've worked on Python backends, but this is like my first Python backend from scratch that actually does something useful. So yeah, I was kind of mostly actually just figuring out how to get, Google Cloud storage and uploading, downloading, kind of that typical thing. With Node.js, I always did it pretty quickly, but with Python, it's like different client docs and they're formatted differently, and it's kind of just weird in the beginning. So that was kind of just getting kind of more acquainted with just building an app in Python. Yeah, so that was definitely one of the roadblocks. And the other one was also just some tasks took a long time to complete. So like when I was trying out kernel PCA, it took Google Colab like a few hours just to train the PCA, like loading vectors. So yeah, it was really just really slow. And I'm in the process of building a computer that can kind of do that locally, but I had to rely on these notebooks and it just took forever. So yeah, that was definitely a blocker.
And what's your favorite thing about this project?
I think maybe, I mean, that it works, I guess. I guess it works to some extent, and I'm kind of happy with that. Although I know it's kind of limitations, so I kind of want to improve. But yeah, I'm happy that it kind of works, and yeah, and that also I was able to learn a little bit more about data science as well. So yeah, that was good.
That's pretty cool. Do you think that if you had a better camera, is there any difference, or it doesn't matter?
Yeah, exactly. So that's a good question. So I mean, if I had, for example, a lower resolution camera, yeah, it's possible that like theoretically, that if there's only one person that has a really low resolution camera in the database, so then it might just recognize if you're using a really low, as that really low resolution user. That's just a hypothetical, but I think it could maybe happen if we're talking about like really small, like to the point where you could see the pixels, that type of resolution. But as for higher resolutions, I don't think it would be a problem. Yeah.
Cool. It's a pretty cool project. Does anyone have more questions for Alejandro?
Yeah.
No?
It's recorded, right? I missed the first half, so but it looks like you can log in just with your face. I love it. You can create an account and log in just face.
Yeah,
that's cool.
good.
That's cool.
Yeah, you can log into Helix with your face or something.
Yeah, exactly. Yeah.
Yeah,
Cool.
I'll demo once more just to make sure.
Yeah, the other day we were just joking, every engineer has their own coding style, right? So maybe we should use any individual's coding style as a unique signature so that you can log in with your GitHub. And, anyways, I was just joking around, but not by GitHub account, but actually by your source code, signature, right? It's like your fingerprint. The way you write code, the way you write comment, everybody's different.
That's a good idea.
Oh, hello. Sorry, my internet is a bit troublesome. Anyways.
Yeah, definitely. No, that's good to see that. Browser fingerprinting. Oh, hello.
Hello.
Yeah, I was gonna say it's kind of like browser fingerprinting, where you can just get it to like a really small percentage that like I'm like 99, get it down to like 100% thingy. Yeah. Is there any other questions for me?
All right.
You guys still hear me? I don't know if my it's been dropping out.
It's very choppy.
You're going out again.
But
yeah, that was good.
Okay,
Great job.
it's a good job. Yeah, it's a pretty cool demo.
Thanks, Alex.
Awesome. I'm glad you guys liked it. All right, thanks, guys.
Thank you so much.
Okay.